So things are getting interesting as we continue to produce, isolate, and define the properties of new gases. So now let's jump over from England to France, where I mentioned in the last video, new ideas were percolating on the study of gases. And so it's 1773, pacing back and forth in his small chemistry lab at the back of his house, Antoine Lavoisier sees his wife Marie-Anne Pierrette Palsy standing in a doorway. His thoughts turn to words. Marie, 7 years ago I was awarded the gold medal by none other than King Louis XV for developing the most efficient street lamps for lighting up Paris in the evenings. I've been inducted into the French Academy of Sciences. I have provided expertise on major public works projects throughout Paris and the entire country of France. And I've launched educational institutions bringing science to the general French public. On top of all this, we've been blessed with an immense fortune. At the age of 11, I inherited the equivalent of $2 million from my maternal great-grandfather. This, as you know, was in 1743. And my great-grandmother died in 1768. And at that point in time, we inherited yet another fortune. Let's you and I capitalize on this wealth, do something good with it, and build a laboratory right here in our home, filled with the best scientific equipment and glassware in the world. Maria is excited. She is keenly aware of the injustice that women are generally disallowed from pursuing science professionally, and she is keenly aware that none of her husband's accolades would have been possible without her equal contributions. But she's also grateful to be in this unique position, married to a famous scientist, to pursue her own scientific passions as a team with her husband. Let's do this, Antoine. We can bring French science to #1 in the world. We can beat the British and the Germans. I've studied the progress made by the scientists from these two great nations, and I've translated and studied all of Joseph Priestley's impressive body of work on gases and the theory of phlogiston from English to French. These two nations are ahead of us now for sure, but we can lead. We can become #1. Back up, Marie. Theory of phlogiston? I'm afraid I'm not familiar with this idea. Marie says, this theory stipulates that phlogiston is released when anything burns. The release of phlogiston is what burning is. Metals, paper, wood, and candles all release phlogiston when they burn. She continues as Lavoisier stops pacing, listening more intently. What remains after burning anything is essentially the part of the substance that was not phlogiston. This is ash for wood and paper, and he called it, Joseph Priestley called it calc for the remains of burnt metal. So when you burn metal, what's left behind is this thing called calc. And calc is interesting. When you burn metal and form calc, you can treat the calc and actually get the metal back, which is remarkable. Because of course there's no way to get a tree back after you burn a tree. There's no way to get paper or wood back after you burn paper or wood. But if you burn metal, you can actually treat it and get it back. This is interesting and unexplained. So let me outline the problem as I see it. In high temperatures, both of these reactions are possible. So iron calc, which again is burnt iron, it's also known as rust. If you react that in heat with charcoal, which is carbon, you get back pure iron and you release fixed air. Mercury calc is a slightly different reaction with mercury calc, which again is burnt mercury metal. If you just simply heat it without reacting with anything else, you get back pure burnt mercury metal. But in this case, you don't release fixed air, you release oxygen. So the pure metal can be recovered from the burnt remains of iron and mercury. Interesting. But why are there two methods? No one knows this yet. How does carbon, which is essentially the same thing as ash, help recover iron from iron calc? And when mercury is burned, it produces mercury calc as expected. Then where does the oxygen come from when you heat mercury calc? Antoine finally interjects, whoa, this is a lot to digest. And keep in mind, Antoine Lavoisier was probably one of the most famous was the most famous scientist in France at this time, if not around the world, and today is deemed as the founder of modern chemistry. And he was confused. So we definitely need the best lab money can buy if we're to answer these questions. He was kind of correct on that. For now, though, let's investigate the properties of fixed air produced in the first equation. Let's just start there. We know oxygen relights a burning ember, but how does fixed air interact with fire? How does fixed air impact the acidity of water?